Hi, and welcome back. And let's jump right into the map, filter, and zip functions, as well as the list comprehensions. So we'll start by defining a small function. Let's do a factorial function that's going to calculate the factorial of its argument n. So we're going to return 1 if n is less than 2, else we're going to return n times factorial of n minus 1. Okay, so that's a simple recursive definition for the factorial. So we can call factorial of 3, which should be 6, factorial of 4, which should be 24, and so on. And let's suppose that now we want to calculate the factorial of a bunch of numbers, and we want to put that into a list. Well, we can do that using the map. So map is going to apply our function. So here's our function, fact. You'll notice I do not have parentheses, right? We're not calling the function, we're just specifying the function. Map is a higher order function. Its first argument is a function. And what do we want to apply this to? Well, maybe I want to apply it to 1, 2, 3, 4, 5, or even simpler, I'm going to say range of 6, right? That's going to go 0, 1, 2, 3, 4, 5. And if we do this, we get a map back. We get an iterator. This is not a list. Now we can iterate through it, or we can convert it to a list, whatever. So let me go ahead and assign this to results. Okay, so if we print results, this is what we have, right? We have our map. So we can iterate for x in results. We can say print x, and we get this back. 1, 1, 2, 6, 24, 120, right? Factorial of 0 is 1. So we can do this as many times as we want, right? We have our results for x in results. Let's just run the same piece of code again, and we get nothing. What happened? Well, here's what happens, especially, and this really is in Python 3. This wasn't the case in Python 2. But in Python 3, map and filter and zip don't return lists or tuples or anything like that. They return generators. They return something that basically doesn't pre-calculate. So when we've actually created this map object, we actually haven't calculated the factorial yet. But when we request the items by iterating through this object, then Python goes ahead and calculates and makes the calculations as we request it. If we had only requested the first 3 elements of this results here, then it would only have calculated the first 3. It wouldn't have calculated the remaining ones. So that's pretty handy because it means that you're deferring your calculations to the time when you actually need them and not doing them ahead of time and potentially not even using them. So of course, this could be a problem because if you want to reuse, let's say, results multiple times, well, you can't, right? So in fact, what we would need to do in this case is turn it into a list. That will actually put it into a list. That will now calculate everything and make a list out of it. So now when we print the results, we actually have a list. So just something to keep in mind. And we'll get back to that a little bit later as well. So let's go ahead and let's see how we might use now the map to add elements from 2 different lists. So let's say we have L1 equals 1, 2, 3, 4, 5, and L2 equals 10, 20, 30. Right, so we have 3 elements in the second list, 5 elements in the first list, and we want to add up the elements from the list. Obviously, we can only add up for as long, for the shortest list of the 2, so it's going to be 10, 20, and 30. Now, we can go ahead and do it this way. Results equals list, so now I'm just going to put my list right away. And then map, now what do I want? Well, I'm going to use a lambda. So here I'm going to take a lambda that takes in 2 values, because I'm going to get, right, values from L1 and L2, and it's going to return the sum, and it's going to do this using L1 and L2. So if we print our results, we get 11, 22, 33, which is what we expected. Now we can expand this further. We can say L3 equals, let's say, 100, 200, 300, 400. Okay, so again, uneven length, but it's only going to run as long as one of them, for as long as one of them has not been exhausted. So as soon as one of these lists is exhausted, the whole thing will stop. So in this case, we'll just deal with the first 3 elements of each list. Now it doesn't have to be a list. This could just be a tuple. That's fine too. So let's go ahead and change that. So now our function needs to take in 3 arguments, and it's going to return x plus y plus z, and we have to give it 3 sequences. I guess I have to run this first. Okay. And now if we print our results, we get 111, 222, 333. Now I want to show you something, going back to the fact that map doesn't actually return a list. Let's do this. Let's say results equals map, and let's map lambda x comma y is x plus y with L1, L2, and L3. Remember what I said? That this function here needs to take in as many arguments as you specify iterables here. Well, in this case, we've supplied 3 lists, or 3 iterables, and this function only takes 2, so that should give us an error. But it doesn't. You can even print results out. What does it tell us? It just tells us it's a map object. Okay, let's iterate through it. Let's see what we get. And now we get an error. It says lambda takes 2 positional arguments, but 3 were given. Yeah, right? We're passing in 3. We're passing in a tuple, basically. That's 3. It's not a tuple, but it's 3 values from these 3 iterables. But you'll notice we didn't get the error until we actually started the iteration. Why? Because again, it doesn't actually make the calculation right away. It defers that until you actually request items from that new iterable. And this is why the error doesn't show up until this point here. So next, let's look at the filter function. So the filter function is just a way for us to filter a list. So let's say we have the following. We have x equals range of, let's say, 25. And if I print x, what do I get? Well, I get this range object. Again, it's not a list. In fact, that range hasn't even been calculated yet. It's only once I request the items that it calculates it. So let's take a look at that. Let's say for x in range 25, print x. Well, I made x equal to range. Okay, so let me say for I in x, because this is what I want to show you first. We're going to print I. And so we get what we expect, right? We get 0 through 24. Let's go ahead and copy this. And let's do that again. And we get, again, 0 through 24. So the range, unlike the map and the filter, we can reuse. Okay, so just something to keep in mind. We can reuse it as often as we want. Okay. So now let's go ahead and filter this range out. Now we only want to keep, let's say, values that are divisible by 3. Right? I know we did even in the lecture. Let's do divisible by 3 in this case. So we're going to want to do a filter. We're going to use a lambda expression. We're going to take a single argument, and we're going to test to see if x mod 3 is equal to 0. If it is, then we want to retain the element. And so now we just pass in our range 25. And of course, I'm going to throw this into a list right away because filter behaves the same way as map. It doesn't actually do the evaluations until you actually request the elements. So I'm going to do that by putting it into a list. And so you can see that we only get items that are divisible by 3. Well, 0 is divisible by 3 because its remainder is 0, right? 3, 6, 9, 12, etc. They're all divisible by 3. So that's the filter function. Now, you can also use the filter function using no function at all as the argument, right, for func. And what it will do, it will just look at the truthiness of each element in that list or sequence that you pass in, that iterable that you pass in, and only retain those ones. So let's take a look at that. So we're going to pass in none for our function, right? So none isn't a function, but it's acting as the function here. We're specifying none, right? And then we have some iterable that we have to pass in here. So let's go ahead and create some list, and let's say 1 and 0 and 4 and a and the empty string and maybe the none object and maybe true and false, let's say. Okay, and what do we get? Well, we get this filter. So again, we need to put it into a list if we want to see quickly what's going on. So 1 was retained, 1 is truthy, 0 is falsy, so it was thrown out, 4 is truthy, it stayed, the string a state is truthy, the empty string is falsy, so it's gone, true is obviously truthy, and false is falsy, so it got tossed out. Right? So that's how you can use filter. So next thing that I want to look at are list comprehensions. And before we do that, I want to look at the zip function pretty quickly. So the zip function, remember, from the lecture allows you to zip together one or two or more sequence types, right? Two or more iterables. So let's say we have our first iterable is 1, 2, 3, 4. Okay, maybe our second iterable is 10, 20, 30, 40. And let's say our third iterable is a string, Python, let's say. Okay, so here we have these three. And we can zip them together. And what do we get? Well, we get this zip object back. So once again, we have to be careful. This is not a list. So if I make this results equal to zip, now we can iterate through that. For x in results, print x. What do we get? Well, we get tuples back. We get 110p, 220y, 330t, and so on. And it stops at the shortest one, which is with 4. So the remaining characters in Python are left out. Now, what happens if I try and do this again? I get nothing back. Why? Well, again, zip defers the calculation until you request it, but it's a generator. It's not a list, which means that once you've exhausted this generator, you're done. You can't go back. If you want to be able to go back, then you should put it into a list. Right? And now you can do it as many times as you want. So that's the zip function. And that's really useful for doing a variety of things. You may want to, for example, zip up. Let's say that we want to zip a range, and I'll make a range of 10,000. It doesn't matter, I'm making it real big. And I'm going to take the string Python, let's say. Okay, so if I zip that up, what's going to happen? Well, range is going to be 0 to 99, well, whatever number of 9s. And then the second iterable is Python, which is a string of characters, a sequence of characters. And it's going to stop at the shortest one, right? So I know that's why it doesn't matter what I specify for the range here. As long as it's large enough to cover the number of characters in my string, I'll be able to index them. So again, I get my zip object back. So here, I'm just going to put a list and get it back. And so here we have 0p, 1y, 2t, and so on. So that allowed us to get both the index and the character in the string. So it's a very handy way for doing things like that. So now that we have zip, let's go ahead and see how we might use list comprehensions to emulate map and filter, as we saw in the lecture. So let's go back to our factorial function. So let's say L equals range of 10, right? So this is going to be 0 through 9. So if we print L, well, we get a range, right? So what do we need to do? We need to print list of L if we want to see what it is, 0 through 9. And again, we can do this multiple times. Range behaves a little differently than the other generators that we've seen. So let's go ahead and now calculate the factorial of each of those things. Well, remember, before we would have had to do map fact L, and we throw that into a list, and we get our factorials here. Well, we can use a list comprehension to do the same thing. We can say results equals, and then we'll do square brackets for a list, right? We're creating a list. And what do we want? Well, we want the factorial of n for n in range 10. And if we print the results out, we get that same list. Now, the difference is that this actually created a list, not something that was, whose calculation was deferred. So in that sense, map is better than the list comprehension because it doesn't, well, it's better in some cases, because it doesn't actually do the calculations until they're requested, which means that if you don't request all of them, it won't do all the calculations. Whereas this one will perform all the factorial calculations, whether you iterate through this or not. So of course, there is a way to do that in Python as well. Those are called generator expressions. And basically, we're going to take the same thing here, the same content, but we're going to use round parentheses. So now if we print results, it tells us it's a generator object. So this is similar to map and filter and zip. It doesn't actually calculate everything. Nothing has been calculated at that point. And we'll see that in much more detail later on in this course. But I just want to show you right now. So if I iterate results, right, we can do this and we get this back, right? We get 1, 1. So here we have the same items that we had in this list. But if I try and run this again, then I get the same problem or the same thing, which is that my results iteration has been exhausted. It's an iterator. It's been exhausted. I can't go back. So what do I need to do in that case? Well, I need to make it into a list, right? So we'd have to put it into a list. We could say results equals, and then we could put list around that, right? Now, of course, we need the generator inside, so we need to put another set of parentheses. And now, if we print, well, I can just print results this way, we get that back. But of course, there's no point. If you're going to do this, when you transform that into a list, when you're making a list out of this generator, it is now iterating through every element, every result of that generator, and putting it into a list. So you might as well just use the list comprehension syntax. Okay, this way. So however you want to do it, and we'll get back to generators and list comprehensions and dictionary comprehensions later on in this course. But do note that we do have a similar way of doing things as map and filter in terms of deferred calculations. For the next example, let's take a look at how we might do a list comprehension when we're dealing with two sequence types, two iterables, just like we had in the beginning when we were adding elements of two sequences. So let's take two lists. Let's say 1, 2, 3, 4, 5, 6. Let's take L2 equal to 10, 20, 30, 40. And we want to add elements from L1 and L2. So let's go ahead and do that. We saw how to do this using map, right? Before. We just had to do something like this just to recall. And actually, I'm going to put a list over there right away. So map, we're going to take a lambda expression. It's going to take two arguments. It's going to add those arguments up, and we're going to apply this to L1 and L2. And got to put in my extra parentheses, and there we go. Now we can do this using a list comprehension or a generator expression, however you want to do it. And here, what are we going to want to do? Well, we're going to want to add x plus y, and this is for x comma y in zip of L1 and L2, right? So we're going to zip L1, L2 up, which means now we're going to end up with an iterable that contains tuples. The tuples, there's two elements in the tuples because we have two lists here. So we can unpack them into x and y as we do the iteration. And then we're going to work with x and y, add them together, and that will form the elements for the new list. So if we do that, we get the same thing, 11, 22, 33, 44. Now, we can also add filtering in there. Let's say that we want to filter this list, and we will only want to keep elements in here that are even. How might we want to do that? Well, what we'd have to do is we'd have to write a filter. We'd have to say filter. Now we'll have to have a lambda that calculates whether something is even or not, which means is it divisible by 2. So we'd say x div 2 mod 2, equals 0. That's how we're going to define or determine if something is even or not. What are we going to pass in there? Well, we want to pass whatever generated this list here, which was this map over here. So let's go ahead and put that in. Okay, and then lastly, we want to make this into a list, so we have to put a list. So now if we do this, we only get 22 and 44 back, which is indeed correct, right? 11 and 33 are odd, they got tossed out. So this is one way of doing it, using the map and the filter. It's kind of reversed, right? You have to do your map inside, you got to calculate your map first, and then you have to do your filter. So instead, you could use a list comprehension to do the following. What do we want to return? We want to return, well, first of all, let's start with the iteration. We're going to iterate for x comma y in zip, L1 comma L2. Okay, so we're going to iterate through those tuples. And what are we going to return? We're going to return x plus y, right? Well, what do we want? We only want to keep it if x plus y is even. So we're going to say if x plus y mod 2 is equal to 0. Okay? So here's our list comprehension, and we get the same thing back. Okay? You'll notice that we have this if statement here that's going to perform the filtering for us. So if x plus y mod 2 is 0, then we're going to keep this iteration and we're going to return x plus y, given that x and y are being iterated through this zip, which is basically a collection of tuples made up of L1 and L2. All right, so as you can see, you can use either the map and the filter functions. Now again, this is resulting in a list. If you want, you can make it a generator, which means it doesn't actually calculate everything until you request it, right? So if I print results, it's just going to be a generator, and we don't have actually any calculations done. That's been deferred until we actually iterate through it. So by doing something like this iterates through it and generates an actual list out of it. And again, we just get 22 and 44 out. All right, so thanks for watching, and I'll see you in the next video.